Good afternoon, teacher. For this video exam, I choose the program with the step-down chopper and the book converter. Where now that the main question is to state the difference between these two circuits and to simulate them, I will start first explain what is a step-down chopper. So first, as we can see on the following figure that I'm going to show, just share it. We can see here a step-down chopper. For this, we need different components, which is the input voltage, Vs, the chopper that is presented as a switch, the inductor, a diode that is in parallel with the voltage source, and a load that is in series with the inductor. So now, what is the step-down chopper? It is a component of a static circuit that will step down the input voltage of the source, the input voltage of the source. Moreover, the output voltage of the chopper is lower than the input voltage of the fixed source. This means that Bs will be greater than Bout, that this Bout will be presented here. So what happened? So this happens because of its working principle that consists of a switch that I was telling you, this one here, that will open and close the circuit, which will be switch on and switch off, and it will do it in a certain frequency. This frequency is called chopping frequency. So what about the chopper voltage? When we have the input voltage of Vs, we will have a behavior when the chopper is on that will be the circuit tending to be having the same voltage at the voltage source, and when the switch is closed or when it opens the circuit, the voltage will decrease immediately to zero. And what happens with the current? Well, when the chopper is on, the current will rise in a straight line. Thus, the chopping frequency is high and will take a moment to be at its highest due to the time required to charge the inductor. Once the circuit is off, for example, we have here the circuit is on, here the circuit is off, the current will decrease linearly, like this. Once again, due to the time needed for inductor to discharge the current. And this will be repeating all the time. Go on and go on. So now we're going to simulate a step-down chopper so you can see, so we can show it better. Here, we can see here the circuit, and when we simulate it, we can see immediately that the input voltage of 20 volts is decreased up to 10.02 volts. And once that we click here in the scope, we can see the behavior of the voltage and the current. We can see here the voltage, which is in yellow, that is in a frequency going to 20 and then going back to 0. And the current, as we said, is changing during time. So it means that it will have, that is a straight line with an inclination. And this phenomena will make the voltage that we said before to decrease. So what happens now with a boost converter? I'm going to show immediately this. So we have here the boost converter. We have the same components: ABS, a switch, inductor, a diode, a load, and we have here a capacitor. When the switch is closed, or when the system is being alimented by the source, the current in the load will tend to be as the same current of the battery, delivered by the battery. But once the switch is open, the current of the resistance will tend to be the same of the inductance. These signs, the diode allows the circuits to keep going and to reabsorb the energy that the inductance is losing. Well, and two, with a little help of the capacitor. So this means that when the current is increasing, or when the switch is closed, the magnetic field of the inductance will be higher. And when the switch is off, or when it is open, the inductance will tend to decrease, and thus the current in the inductance will decrease as well. So where is the difference between the chopper and the boost converter? It relies mainly in that the chopper reduces the voltage by having a loss in its energy. And this energy loss is experienced as heat generation in the inductance. On the other hand, the boost converter doesn't have this energy loss, or at least it reduces this energy loss. What it does is that it reduces the voltage while increasing the current. So in small words, the boost converter is a most efficient and sophisticated way to reduce the voltage without losing much energy. Now we're going to show the simulation of the boost converter here. So run it, and we're going to see here in the current that, let me close it again. We're going to do it really fast. Okay, so we are here with the boost converter simulation. We run it, and first we're going to see here in the voltage that it is, as in the chopper, going to the voltage source and then it decreasing to zero. All the same. And what's interesting is here. We click here, we're gonna see that the current is changing according to the energy that is contained in the inductance and the capacitor. The voltage will be changing, but mainly the power will be constant and will tend to stop having energy losses. So from this simulation, we can see that the output voltage will be again change all the time, but trying to be in a fixed point. This scale is multiplied by 100, so this will be an output voltage of approximately 5 volts. Oh, sorry, of 0.5 volts from the 1 volt that is being delivered by the source. So I hope you have enjoyed and that you have a wonderful time. Thank you very much.